My name is Kim Awa, and I'm a research scientist with the Art Bridges Foundation. Today, we're going to talk about the Music of the Mind project, the collaboration between Art Bridges Foundation and the Crystal Bridges Museum of American Art, where we aim to understand what happened in people's brains when they were experiencing the James Turrell Skyspace. This project was a really collaborative effort that was inspired by bridging the gap between the arts and sciences. And so many times people are viewing these two fields as separate entities. I've always been drawn to spaces where the two overlap, and so the Skyspace, it's a perfect setting for that exploration. It's dynamic, it's immersive, it's emotive. So that variability made me really wonder then how brain activity would reflect those differences. EEG, also known as electroencephalography, is a non-invasive way to measure the brain's electrical activity through sensors placed on the scalp. What we had people do is come into the space and wear an EEG cap and collect people's brain data in real time. Light, sound, color, all of these modalities are some of the most powerful sensory inputs that we have. They influence mood, attention, and even the way that we perceive time. So in the Skyspace, these gradual shifts in light and color are not just visual cues. They trigger deep changes in how our brain processes our overall experience in the space. So it's not just about measuring brain activity, it's about learning how sensory experiences work together to move us. So by collecting the electrical activity that's emitting from people's brains while they're experiencing the James Turrell Skyspace, those states reflect the way that people are engaged. So for example, slower waves are linked to relaxation, and faster waves are linked to focus. When they all are blended together, they sound extremely beautiful and harmonious, which is very reflective of the benefits of engaging in these spaces. Before anything is turned into music, I first have to translate the neural data into 5 primary bands that are typically looked at in neuroscience research. So delta, theta, alpha, beta, and gamma. Each of these 5 bands reflects a different cognitive state, such as attention, memory, creativity, and insight, which helps us then further on translate these different bands into different sounds. After processing the neural data, I then work very closely in collaboration with musician Chaz Knapp. It's important to stress that we're not composing anything, but instead we're making careful artistic translational choices, because the brain is driving the process. We are just simply sculpting how it's expressed sonically. On the more technical side, we use Python to convert the EEG into a music file. Chaz also layered in field recordings captured during the sessions, such as bugs humming, whispered conversations, the footsteps outside. This means that when someone listens to the final piece, they're not only hearing how the brain responded moment to moment, but also the moment-to-moment sounds of the natural environment. My hope is that at the end of this project, it inspires other researchers, not just research scientists, but art researchers, people in a museum, working artists, any person to push the boundaries of what it means to understand the human experience. Collaborations and projects like this, I believe, are the future of neuroscience research. We have all of this rich scientific understanding of what's happening in the lab, but we need to have this shift to understand the emotional impacts that these spaces have in real time, moment to moment. The real goal is to create an emotional bridge. When they hear their brain as music, I want people to feel that their mind is not just an abstract data point, but something that's alive and creative.